Hey, what's up, guys? Jeremy here. So, I'm super happy today to present at the Omron Robotic Days. I prepared a very special presentation for this event. The title of this presentation is simply Simulation and Offline Programming, the Key to Successful Robotic Integration. Before jumping into it, let me introduce myself. For those who don't know me, my name is Jeremy, followed by a very French name that you don't need to remember. So just call me Jeremy. So I'm the product manager here at RoboDK. That's a pretty vague title, I would say, and my tasks are cover a pretty wide range of things. So I will do things like technical things like coding, robot integration between RoboDK and robots. I will supervise some feature development. I'll be involved in sales, marketing, technical support. I'm in charge of most of the training, and I do most of the training videos you will find on our YouTube channel. So more on that later. I've been in the field of robotics for about 10 years now, so I'm honestly very passionate about that field. I very fell in love with it the first time I had a project when I was doing my bachelor degree. So I have a bachelor degree in automation and a master degree in robotics. So this is where I really discovered the field. I joined RoboDK 3 years ago, and honestly, I enjoyed every single day working here. So enough about me. Let's talk about RoboDK itself. So RoboDK was started as a student project, university project in the early 2010. It was a way to simulate what was coded by the student in a robotic precision lab here in Montreal. And as time passed, it evolved into a software, so around 2012. And in 2015, it was officially launched as a company and a product. So we just celebrated our 7th anniversary in early January. So really proud of that. We are based in Montreal, Canada. So all of our development, technical support, marketing, training is done from here. So that will explain part of my French accent. We have a relatively small team, but we are growing quite quickly. So we doubled the size of our team in the last year. So we're pretty proud of that. Things are going well on our end. As you may know, we have a pretty extensive robot library. We are what we call a robot agnostic software. So we support a bunch of different robot brands, and we have a bunch of different robots in our library. So we support over 30 different brands. We have over 800 different robots in our library, and we are constantly adding more every single week. For the purpose of this presentation, we obviously have all the Omron TM robots in our library. So from the small TM5 700 up to the bigger TM12 and TM14. We also support the Omron Adept lineup. So you can find all of this on top of a bunch of other brands. So I was in charge of most of the integration. So I did most of the integration between RoboDK and the Omron TM lineup myself. So I know it quite a bit. And before jumping into the presentation, I want to give us a quick shout out to quick mention to one of Omron representative here in Quebec, Yannick Bertrand, who was key in this integration and this collaboration. Without him, we wouldn't have such a good integration and such a good relationship with Omron. So thanks for that, Yannick. Okay, so my goal for today's presentation in the next 25 minutes or so is for you to understand why a simulation tool is something you should add in your robotic integration workflow. So what are the benefits of that kind of tool, what you can get out of it, and why it's totally worth the investment in time. It's worth investing the time to simulate your process before moving forward with the actual installation. So to convince you of that, I will split my presentation in 3 topics. The first one will be risk or risk management or risk reduction. So we all know that robotics is a risky business. It's always a bit custom, so we have to deal with that risk. Cobots were part of that risk management process, being able to lower down the barrier, make a secure product without having all the security feature. I still love standard industrial robot. I think that cobots are a great complement to that, and reduce in some aspects the financial risks of robot integration. So I will talk about how simulation can also play a role in that. We will then talk about how simulation software can help you with the cell process of robots. So obviously, risk reduction will impact cells. So all the topics I will talk today will be kind of interrelated. So yeah, how a simulation software can help you in that regard. I will also talk about advanced robotics. So how a simulation offline programming software can help you tackle more advanced application that you wouldn't have thought to even think about programming, in fact, or think about investigating before, for many reasons that we will discuss. So let's talk about risk. So like I said, robotics and automation is a relatively risky business. And this is mostly because of one thing. And here's a quick quote. If there is one standard in automation, it's that there are no standard applications. So what I mean by that is that even if you do almost the same thing, it's never exactly the same thing. It's never the same part. It's never the same layout. It's never the same machine that you are tending. There's always a little something that is different from the last project. So there's always a bit of uncertainty, and that uncertainty brings risk with it. So it can be a matter of like, are you able to reach all the positions in your station? Are you free of any collisions in the way you build your layout or you assembled your layout? Will you be facing singularities when it comes to time to programming the robot? Are you using a custom tool? Will that custom tool do the job? Will it interfere with the jig, the table, the machine that you are feeding? Is your layout tight enough, small enough? Do you need more space? Is the cycle time within an acceptable, let's say, range for the customer for it to make this, let's say, integration process or robotic integration process even worth it? So those are all things that bring risk and can be mitigated. You can never remove all the risk, but those can be highly mitigated by using a simulation software. The goal of a simulation software is for you to learn as much as possible about the integration project you are actively working on, without having to invest a massive amount of money in buying the equipment and then testing it out. So if you invest in a few hours in building out the station in the 3D environment, creating the program, you will learn a lot about your process, and you might decide to do changes to your let's say first idea, first plan, so that you avoid some of the common traps, let's say, related to robotics integration. So here a quick example of a machine tending process. I know that no one would do a machine tending with conveyors like that. When I did this demo, I was testing out a few features at the same time, so double gripper conveyors. But here's the point. You can at all times showcase the workspace of your robot so that you can make sure that all the targets that you are trying to reach are effectively within reach of the robot. So that's a very important point. Simple but important point, like, are all the points I need to touch within reach? You can then make sure, you can then position properly your targets so that they really are within the reach of the robot. So if I go back just a second here, if you move the target into 3D environment, like it will detach itself from the robot and become red if it's out of reach, and then reattach when it comes in. Same for more advanced path, let's say welding, cutting, dispensing, sanding, stuff like that. You can make sure that the targets are always within reach, free of collisions, free of joint limits here, free of singularities, all of that stuff before you even bolt in a robot to in the real environment. I just mentioned collision. RoboDK or estimation software will help you figure out if there is collision in your station. So if you activate the small collision checking button here in RoboDK and you run your program, if there's a collision, obviously this one is obvious, it will stop the program and show which items or which objects in your station are colliding. So you will save time and potentially money by not crashing expensive tools with your part. You'll also be able to have a good idea or a good estimation of the cycle time of a given project. So I have to mention here, it's a cycle time estimation, not a cycle time calculation. So it's like accurate calculation. From my experience, and if you set up RoboDK properly, you can have this estimation within a few % of the actual real cycle time. If you say, okay, I already tested RoboDK for that purpose and the cycle time was like completely in the left field, it didn't make any sense, that may be because you didn't properly set up your RoboDK station. There's a few parameters that you need to understand how to work with, and I know it's not trivial, so I created a tutorial video on that specific topic that will be released in the near future on our YouTube channel. If you need that tutorial before, you can always contact me directly. I will give you access to that specific video, or in fact a series of video related to speed, rounding, acceleration, and cycle time estimation. So those are all linked together, obviously. So if you don't set your speed or rounding properly, the cycle time won't make sense. You can also make sure that your layout makes sense, that is tight enough. You can move easily your, let's say, a tray full of parts around your station to try to test new layout and see, okay, maybe this one will help me gain a few seconds if I move this part here or move that assembly process there. It's going to be better and free of collision. So that's always easier to modify your layout in a virtual 3D environment than doing so when the robot is installed in the field and you're kind of, oh, damn, the robot is bolted. I need to kind of unbolt the robot, change the position of this jig or change the position of this rack of parts and stuff like that. This is not ideal, let's be honest. So that's kind of quickly how a simulation software can help you mitigate or reduce the risk inherent to robotic integration. So as I said, all robotic integration are a bit custom. So having a way of pre-planning, pre-working, brainstorming with respect to your robotic station or robotic integration, the time you'll invest here, you will save like many folds when it comes to actually installing the robot. Okay, now let's talk about the sales aspect of things. So how a simulation software can help you sell more robots or install more robots. So obviously, like I said before, it goes down. It's linked with the risk reduction. Obviously, if you reduce the risk, you will be able to sell, to do better sales, and you'll be able to have to create better quotes that will be more accurate with the actual job involved in a given project. So like no one's want to be in a situation where you quote a project for a customer and then you end up realizing later that it's way more complicated than you thought, and it's going to be a cost way more than you expected, and then you are in a financial nightmare. So no one want to be there. So simulation will help you, like I said, figure out what are the real process. And obviously, you don't need to create simulations that are as let's say, polished as the one I will present today. Like sometimes just bringing a robot floating in midair, moving a part around, figuring out where you want to put the tray in the part, or where you want the well, where you want to dispense. That's enough. Like now I'm kind of showcasing nice looking simulation, but you don't need to go up to that level of detail if your goal is just to evaluate the project. But if your goal is to use the simulation to actually sell your project, so I'll talk with my experience. Before joining RoboDK, I had a startup. I was a founder of a startup where we were trying to robotize or automate part of the hospital pharmacy oral fitting process. Anyway, the point is that I was going from hospital to hospital, and they had a problem. I was gathering the information. They had a problem. I knew I had a solution for them, but I had a hard time, let's say, making them understand really what I was trying to propose as a solution. Those people were pharmacists. They knew about medicines. They didn't know about medicines. They knew about drugs. They didn't know about robotics. But when I took the time to create a RoboDK simulation of the process, first of all, it helped me figure out what I really needed from a technical standpoint. But also, I started seeing little stars in their eyes when I was showcasing the simulation, because they finally understood. They got it at that point, and now they understood that I was just, quote unquote, just proposing to use a mechanical arm to do the exact same thing they were doing manually. And this way you can showcase specific technology that you want to use to help them solve their problem. So here, let's say we have a range extender, because we want to create a big pallet here. Maybe we'll need more range than what the cobot can give us. So why not use a range extender? You can also use RoboDK as a kind of a marketing tool. So we have a new feature that we released recently. It's still not completely polished. I will have some improvement to it. But the goal here is to help you create some scenery where you can have a camera kind of moving in your station, so that you can create small videos to showcase either your company, your product, but also bring more impact to the quote that you will present to the end customer, so that it's easier for them to understand why the amount or the cost is X number of euros or dollars. So this is something we work on. Obviously here I recorded the whole screen because I want to show you that it's within RoboDK, but you can always just record the virtual environment and not have what everything is around here. So just to finish with the cell aspect, I was talking with someone from Omron last week. So Barry Graham from the UK. He's a cell representative, and he told me that RoboDK recently helped him sell a robot, and mostly helped him sell a robot without having to invest too much money in that cell. What I mean by that is they had a potential application. They needed to figure out which robot was best suited for that application, and I want to make sure that it made sense in the first place. So instead of sending a robot there, so renting a robot, placing it at the customer place, doing the integration, and then hoping that the client will buy the software at the end, they just had to pre-plan all of that within RoboDK, make sure that it was okay. I'll use a TM12 instead of a TM14 because I need a bit more range, and so on and so forth. And therefore, they were able to have a successful cell without having to go on site with a robot and everything. So that was a big money saver. So he told me that they saved about as much as the price of a RoboDK license just with that project. So as you may know, RoboDK is priced pretty aggressively in the market. So we are, as far as we know, the most affordable simulation software on the market. So just that one project made it worth financially for them. Okay, let's talk about advanced robotics. So what I mean by advanced robotics is everything that is not pick and play. So everything that is not material handling, or that is not everything that is not assembly, let's say, process. According to the IRF, between 2018 and 2020, between 43 and 47% of all robots sold were for applications that were not machine tending or not material handling or assembly process. So between 43 and 47% of all robots were not there to move objects from point A to point B. So my question for you today is, are you missing out on about 40% of the market by just focusing on material handling applications? Material handling applications are awesome. They are a big part of the robotics industry. I'm not going to argue on that, and you should still focus on this aspect as much as you can. But every time you go to a potential customer for an application of material handling, do you keep your eyes open for maybe something a bit more advanced, a welding application, a glue dispensing, sealant dispensing application, surface finishing application, polishing, sanding, deburring, maybe deburring of plastic parts of, I don't know, out of a injection mold machine. So you're already doing the machine tending to take the part out of the injection machine. Why not adding a step and removing the flash with a robot, doing some light machining with a cobot, or heavier machining with an industrial robot, doing some painting, doing some inspection process with a robot, 3D printing even. So those are all applications that can open a lot of doors for new cells of robot and complement the ones you already do. So you may tell me like, okay, that's cool, Jeremy, what you're telling me here, but the problem is those applications are quite complicated to program, and they need to follow a specific path on a part and everything, and that's not something we have the skills to do. And if we were like 5-10 years ago, I would say, yeah, you're right. Like, if you don't have someone with a lot of experience with robots, or you don't have like a programming crack, there is no way you will be able to easily create that type of process, and it won't be worth it. But now, with offline programming softwares, there's a way to do that kind of applications in a matter of a few minutes, like hours, and just with the user interface. No need to know how to code advanced languages and stuff like that. So the offline programming software will take care of that part automatically. So this is kind of how it works in the simulation world. So here, if we take RoboDK, for example, you start from RoboDK, you do your application, your process, your simulation. Then RoboDK, you literally right-click your program, generate robot program. RoboDK will translate that program into whatever language is required for that given robot controller. So in this case, let's say if we generate program for Omron, we'll be able to generate TM flow program or path file. So we'll be able to create the nodes the same way you would have created them manually, but way faster and automatically. If you really are doing some advanced applications like that needs to follow some specific curvature of a part or the specific shape of a part, you can always use one. In fact, we developed a feature that we call CAD to path. So CAD is for computer-aided design, or 3D. You can imagine 3D model to path. So the goal is to import the 3D model of your part inside RoboDK. You create your path, you optimize your path, then you generate the path and load it to the controller, and then you're ready to go. So it's as easy as that. I'll give you an example later. So here, a quick example of a real application. I don't have the real recording, video recording of it, unfortunately, but this is one where we are removing paint, grinding paint off of a propeller here so that we can be reworked afterward. So yeah, it's that simple, as simple as that. So yeah, so that's a cool example. Here the concept was very simple. we just created a 3D sketch on the surface of the propeller, and we used that as a robot trajectory. I'll explain you how it works in a few minutes, but that's pretty much how it went. So we did not program those points one by one. We literally just drew them in a CAD software. Here we have another example where we do some dispensing. So you can decide which orientation you want the tool to be. Like here in this case, we were rotating around Z, but you can decide to have an inclination around Y or X, and so on and so forth. And here we're creating a three-axis dispensing application. RoboDK is also very flexible in terms of what kind of 3D model you can import to create your station. So RoboDK supports STEP, IGES, STL, OBJ. So in this case here, I didn't. So this is the AIM robotic dispenser. I didn't have that in my library last week, so I just sent an email to a message on LinkedIn to the CEO of the company, and she was super nice and sent me the 3D model within like 30 minutes or so. And after that, I just bring it to RoboDK and created a tool with it, and then I switched the tool I had before, and I was able to have this simulation in a matter of a few minutes. Honestly, I already had the simulation. I just switched to this specific tool, but it was very quick and very flexible. You can do, let's say in this case, dispensing in, let's say 3D in XYZ in this case, but you can do it like in this way where you have the tool always normal to the ground, or in this case where the tool is always normal to the surface, which also works pretty well. So you have the flexibility to decide the orientation of your tool. So in this case here, always parallel to or perpendicular to the ground, and here always perpendicular or normal to the surface of the tool. So depending on your application, you can create the path you need. So RoboDK is not a CAD or CAM software. So, and you don't want to be one. We have some features that will help you draw paths and do stuff, extract edges from the 3D model you imported. But if you want to do very advanced stuff, you can use one of our CAD-CAM plugins. So as we say, if you can't beat them, join them. So instead of trying to have all the features that a CAD software would have, which is not our goal, CAD-CAM software are good. CAD and CAM software are good at what they're doing. We decided to create bridges between some of the most used CAD-CAM software and RoboDK, so that you can create paths and trajectories inside that environment and bring it to our software, so that our software can translate that into something that is usable for a robot controller. So we support a bunch of CAD-CAM software: SolidWorks, SolidEdge, Rhino, Fusion, Inventor, MasterCam, BobCAD-CAM, AlphaCam, to name just a few. So like I said, you can create a sketch, let's say in SolidWorks, either 2D or 3D sketch, and then you import it to RoboDK. So this is what we did here. We wanted to do a sanding process on a part that was, in this case, flat, so easy enough in theory, but we wanted to be able to follow that curvature and have kind of the spiral path here. So what we did is we simply created a 2D sketch inside SolidWorks. We bring it to RoboDK, and here we are. And I did the same with Fusion and Inventor and SolidEdge and Rhino. It always worked pretty well. If you have a 3D shape, you can always just create a 2D sketch. You project it on the surface. This is a very common feature in the CAD software, so project to surface. And then you bring the 3D sketch to RoboDK afterwards. So here a real example. So I have here a gear part. So this is the kind of our test part that we use to test our integrations. And here I wanted to follow, I'll go back here. I wanted to follow this edge here. So imagine how long it would take for you to create that program manually by creating targets one by one. So here, this is what I'm doing. On the left, I'm doing the program manually, and on the right, I'm doing the program using RoboDK. So the first thing I do with RoboDK before programming the part itself is taking 3 points on my part to position the part at the right spot in the 3D environment. So you always try to do that. You match the virtual environment with the real environment, not the other way around. So you take 3 points on the part positions itself properly in the virtual environment, and then you start programming. and then I'll start extracting the pieces of the curve. So I did all of that in a few minutes, testing it out, generating the program, loading it on my USB key, and then loading that on to TM-Flow, doing one test, creating a loop with it, and then I was ready to go. On the other hand here, so I did that in like 8 minutes. On the other end here, I was still creating the targets one by one, and then after that, I needed to create the program, adjust the parameters, blending, speed, and so on and so forth, join all of that together. So I had to do a bunch of clicking and stuff, while here with RoboDK's method, I was just cycling through my program. So I was able to cycle through 21 times while I was still programming in RoboDK. And the worst part is that I did that as fast as I could here, because my goal was to try to do it as fast as possible. And the result is far from perfect. First of all, it's not fluid. I'll explain you why in a few seconds. But it's not super accurate if you compare to what I was able to achieve with RoboDK. So 2 points here. First of all, it's not as fluid in with the real method, because I was forced to use TM-Flow, and TM-Flow, when targets are very close to one another, is not very good at keeping a constant velocity, while they have another feature that is a bit hidden but still accessible. I'll just pause that for a second. It's still accessible if you use an offline programming software like ours, where you can use the PAT file. So PAT file are a way to have a program that is very fluid and will run through a bunch of points with a constant velocity with respect to the part. So that's something you can only do with an offline programming software because of the type of points that needs to be generated. So here, just take a look at the accuracy of the pad. Here, the shaft is about 6 or 8 millimeters. So you can see that we are following the edge pretty well here on this flat path. And same here, we are following a surface here and keeping a constant distance on a curved path like this one here. So that's cool. Okay, so a few quick examples. So here, this one doesn't use a TM robot, unfortunately, but this is an example from one of our partner, Kane Robotics in the US. They used RoboDK to create a 3D sketch on that here surface, and they then created a polishing path for that propeller blade. As you can see here, the propeller blade is not a flat surface. It's a very curved and weird surface. And you need to be normal to the surface at all time if you want to be able to have a great surface finish. So here, an offline programming software is the way to make that kind of very hard to program path very easy in a matter of a few minutes. Here, another example. We have another partner here, Wilder System in the US. They did a jet car wash kind of. So obviously you can't have like the plane here sitting here for weeks while you are creating the targets and like walking on the plane, and then when you teach pendant, okay, I'm going to create the target here and the target here. Am I covering the whole area, and then so on and so forth? It would take forever. So what they did is they bring the 3D model within RoboDK, and using a feature called Teach Target on Surface, they just clicked everywhere they wanted the robot to go, and they created the path, the program like that. They then use our API to save some time, and then mirrored the whole program on the other side. So we have a very open API if you know how to code in Python, C#, C++, and C, but you don't need to use that. But if you may be able to save a bunch of time by using some of this, let's say, underlying features of RoboDK. Another example here, a hockey stick company that uses robot to trim the shape of their goalie stick here using industrial robots. So yeah, this is using an industrial robot, but gives you an idea what you can do with RoboDK. So any NC file that you create, so machining file, you can drag and drop to RoboDK, and it will translate that to something that is usable for the robot controller. Okay, real quick, I want to finish with by talking about two of our newest features. So we just recently added support for AVG, so you can now create AVG. This feature will be officially released in not so long. We're just waiting for the designer to create the icon for this feature. So this is an example my colleague did yesterday, where we go and pick parts from one table and place them in the other one on the other one. So simple example, but yeah, it uses an AVG, so that's pretty cool. It was something that was requested for some time now, so we did deliver. And here I know that I'm teasing that feature. I've been teasing that feature for a long time, but now it's officially released. Sorry, we have a palletizing feature, and it's officially released and field tested. So the goal here is to be able to create box patterns that are very, let's say, in a very simple way by just drag and dropping rectangles on a 2D interface, and then you have the 3D interface here showcasing the result. You'll then be able to make sure that your pallet or robot and all the boxes are always within reach of the robot, either the box or the approach motion. So that's also very cool. And then you have the actual simulation. And then, as usual, you can generate the raw program and load that to the controller. So here's a real example of a real project we did with a partner here in the US. So we have here linear track, two pallets, a TM robot, and a conveyor bringing in boxes. This was programmed with our palletizing feature. And yeah, so that's cool here. The cool thing that I like about our palletizing feature, it's not a black box. So it creates a program the same way you would create a program yourself. So that means that if you have to do some small touch-ups to the program, either in RoboDK or later in the field, you can do that. It's not like, okay, here's a palletizing feature, and if it brings you 100% of the way, cool. If it brings you 98% of the way, you can't use it because like of those two targets at the end of the reach were not reachable, and with RoboDK, you can kind of find a way around that maybe. We have full flexibility on how you create your approach and retag, making sure that you don't have two boxes that just barely hit one another. You will see that in the last box here. Here, this box was not exactly placed where we thought it was. So here, and then move the other box exactly where it should be. So this way we don't have a collision that would create an error. Here we have a PLC involved. So the RoboDK tells the robot when to tell the PLC to move. RoboDK is not connected. So this is kind of part of the program RoboDK generates. So it will have a Modbus communication with the Omron PLC to drive the linear axis up and down as required. So yeah, that's pretty much it for this presentation. I hope you liked it. I know there was a lot of stuff. My goal was really to showcase how a simulation and offline programming software can help you in your integration process. I hope you understand that a bit more. If you want to continue the discussion, you can always join me either via email or connect with me on LinkedIn. I'll be happy to have a conversation. This is a great platform to exchange with other automation enthusiasts. I talk about RoboDK obviously, but I talk about robotics and automation in general. So in any case, have a great day, guys.